Welcome to Astronomy Daily, the podcast that brings you the biggest news from across the cosmos. I'm Avery.
And I'm Anna. It's great to be with you. Today, we're talking about a dramatic spacewalk outside the Tiangong space station. Plus, the James Webb Telescope spots the oldest supernova ever seen, and we'll find out why giant planets, known as super Jupiters, might look nothing like our own Jupiter.
And we'll finish with a black hole that's whipping up winds at a fraction of the speed of light. Let's get started.
First up, let's head to low Earth orbit. There's been some serious activity outside the Tiangong space station.
That's right. Two Chinese astronauts from the Shenzhou 21 mission conducted a marathon 8-hour spacewalk. The primary goal was to get a close look at the Shenzhou 20 return capsule.
And what they were looking for was damage, right?
Exactly. The capsule was likely struck by a piece of space junk, and the damage was serious enough that the Shenzhou 20 crew couldn't use it to return home. They had to come back to Earth on a different vehicle as a precaution.
Wow, that really highlights the dangers of space debris. So this spacewalk was essentially a forensic investigation in orbit.
It was. They were meticulously inspecting and photographing the damage to understand exactly what happened. But that wasn't all they did. They also took the opportunity to install new space debris protection systems on the station itself.
A necessary upgrade, it seems. It's a growing problem that isn't going away. Every piece of junk, big or small, is a potential threat to current and future missions.
And speaking of China's space program, they've been busy on the launch pad as well. Incredibly busy, in fact.
You can say that again. They just set a new national record by launching 3 separate Long March rockets in less than 19 hours.
19 hours, that's an astonishing pace. It brings their total for 2025 up to 83 orbital launches already.
So what were these missions carrying?
A couple of different payloads. The launches deployed more broadband satellites for their Guang mega constellation, which is their competitor to systems like Starlink.
Right.
And they also sent up 2 classified military satellites. The details on those, as you'd expect, are pretty sparse.
It just shows the sheer scale and speed of their operations right now. They're not just launching frequently, they're launching with incredible efficiency.
And they seem to be getting better at it with every launch.
Okay, let's shift our focus from Earth orbit to the Red Planet. A major new report from the U.S. National Academies of Sciences, Engineering, and Medicine has just been released, and it's making some bold recommendations for the future of Mars exploration.
It really is. The headline recommendation is that the primary scientific objective for the first crewed missions to Mars should be the search for life, either past or present.
That's a significant statement. For a long time, the focus has been on geology and paving the way for colonization. This report puts astrobiology front and center.
Exactly. It outlines 11 specific science objectives and proposes 2 main science mission campaigns to achieve them. The first campaign would target near-surface glacier ice,
which could preserve biosignatures.
Precisely. The second, even more ambitious campaign would involve exploring the deep subsurface of Mars. They're talking about drilling deep down to where liquid water might still exist, protected from the harsh surface radiation.
That would be an incredible undertaking. The technical challenges alone are immense, but the potential payoff, finding evidence of life on another planet, is arguably the greatest prize in science.
It completely reframes the why of sending humans to Mars. It's not just about planting a flag, it's about answering one of humanity's biggest questions.
It would be nice if we could get a definitive answer one day.
Well, from the search for life to the death of stars, the James Webb Space Telescope has done it again. It's given us a glimpse into the cosmic dawn by finding the oldest supernova ever seen.
This story is just mind-boggling. JWST detected light from a star that exploded 13 billion years ago.
Let that sink in. The universe itself is about 13.7 billion years old. So this event happened just 730 million years after the Big Bang.
Incredible. So what do we know about this event?
It's been designated GRB 250314A. The GRB stands for gamma ray burst, which was detected first.
That burst is the telltale sign of a massive star collapsing into a black hole or neutron star. The supernova is the explosion that follows.
So this breaks the previous record for the most distant supernova?
By a long shot. Observing an event like this from the very early universe gives astronomers a direct look at the life cycle of the first generations of stars, which were much more massive and short-lived than stars like our sun. It's a crucial piece of the puzzle for understanding how the universe evolved.
From the most distant to some of the most massive, let's talk about exoplanets. A new study is challenging what we thought we knew about super Jupiters.
Right. These are gas giants that are significantly more massive than our own Jupiter. This new research focused on an exoplanet called VHS 1256b. It has a mass of about 20 Jupiters.
20 times the mass of Jupiter. That's almost in the territory of a brown dwarf, a failed star.
It's right on that line. And the study suggests that planets this massive might not look like Jupiter at all. We pictured Jupiter with its beautiful, stable, banded cloud patterns.
The Great Red Spot, the distinct zones and belts.
Exactly. But on a world like VHS 1256b, the internal heat and higher temperatures could drive a much more turbulent and chaotic atmosphere. The model suggests that instead of stable bands, you'd see large, dusty silicate storms swirling chaotically.
So less organized beauty, more violent chaos.
That's a good way to put it. It reminds us that our own solar system is just one example, and the diversity of planets out there is far greater than we can imagine.
Well said. And from voyages within our solar system, let's take a leap to the truly cosmic scale. For our final story, we're heading to the center of galaxy NGC 3783, where a supermassive black hole is putting on a spectacular and very windy show.
And this was a coordinated effort between two powerful space telescopes, the XMM Newton and the new XRISM Observatory.
That's right. They observed the black hole's active galactic nucleus, or AGN, as it let out a massive X-ray flare.
So similar to a solar flare from our sun, but on an unimaginable scale.
Precisely. And this flare had a dramatic effect. It triggered powerful winds of superheated gas being blasted away from the black hole at an incredible 1/5 the speed of light.
20% of the speed of light. That's just phenomenal speed.
It really is. And observing this process helps astronomers understand how these central black holes influence their entire host galaxies. These winds are so powerful that they can clear out gas from the galaxy center, which can shut down star formation and fundamentally shape how a galaxy evolves over billions of years.
It's a direct link between the very small, the accretion disk of a black hole, and the very large, the entire galaxy. A fantastic discovery to end on.
And that's all the time we have for today on Astronomy Daily. We covered everything from spacewalks and launch records to the hunt for life on Mars.
And we peered back to the dawn of time with the oldest supernova and questioned what a super Jupiter really looks like. Thanks so much for joining us.
You can find us wherever you get your podcasts or our website, which can be found at astronomydaily.io. We'll be back tomorrow with another roundup of the latest news from the final frontier.
Until then, keep looking up. This is Avery and Anna signing off.